All right, in this installment of Chemistry Introductions, we are going to be learning about what a mole is. And so we've already discussed this a little bit in class. And so basically, a mole of something is a certain number that we say you have when you have the same number, same amount of a substance in grams as what either its atomic mass would be if it's an element, or what the atomic masses of the constituent elements would add to. This concept of a mole is just the most important part of that is that when you have a mole of one substance and a mole of another substance, you have the same number of atoms, and that's going to become really important when we apply this whole quantitative stuff to reactions and what's called stoichiometry, which is our next topic. For now, we just need to be comfortable converting between things. So a mole is 6.02 times 10 to the 23rd things. This is known as Avogadro's number. So this is a really huge number, 602,000 billion. Certainly not the biggest number out there, but it is a huge number. Some facts about a mole. We already watched the mole of atoms video, and you can certainly watch that again if you want. Another one that I can remember off the top of my head would be that a mole of hockey pucks would have the same mass as the moon. So when you're talking about normal size objects like a hockey puck, a mole of them is a huge number of things. When you're talking about a mole of atoms, having a mole of atoms really is not that big of a deal. Okay? Because atoms are really small. Okay? So with moles, we have something called the molar mass, which is the mass of everything in the compound added up in units of grams per mole. So if we want to know what the molar mass of something like helium is, helium, we just look it up on the periodic table, and helium has an atomic mass of, boy, I don't even know my periodic table, I think it's 4. You can double check me, it might be like 4.04 or something like that, but I think it says 4.00 AMUs is what the atomic mass is on the periodic table. Basically, when we're looking at the molar mass, we just say, no, that's units of grams per mole, which means every 1 mole of helium has a mass of 4 grams. For water, we look up on the periodic table. Hydrogen is 1.01. There are 2 of them. Oxygen is 16.00. So all together, that's 18.02 grams per mole. We take something like sodium sulfate. Sodium is 22.99. There are 2 of them. Plus sulfur is 32.06. Plus 4 oxygens. Each oxygen is 16. And that would all add up to whatever. I don't really care right now. I just want to make sure you know how to do it. For ammonium carbonate, because of the 2 in the parentheses, we got to be really careful with this. Nitrogen is 14.01. It's inside the parentheses, and there's a 2 outside the parentheses, so there are 2 nitrogens. Hydrogen is 1.01. There are 4 hydrogens inside the parentheses, and then there's 2 of the whole parentheses, so that is a total of 8 hydrogens in that compound. Plus carbon, just 1, 12.01. Plus the oxygen, there are 3 oxygens. Oxygen is 16.00 times 3. So you add that up and you'll get the molar mass. If you ever want to check, like on homework or whatever, that you're doing this right, there are various molar mass calculators, which this here is one of them. Basically, all you need to do is you just go in and we can check to see on that Na2SO4, whoops, gotta make sure you capitalize that O4, what would it be? Runs it through and it tells you that it is 142.0428 grams per mole. And even down at the bottom gives you what the mass percents are, and we'll learn more about mass percents later on in this unit for the advanced chemistry students, how to calculate those. Okay. So back to what we were doing here. The other thing you have to know when converting between moles is this whole idea of concentration. Concentration basically means how close together are all the moles. And so it has units, the most common units in chemistry is molarity, which means moles per liter. So when I say the word molarity or I say molar, either way I'm going to mean how many moles per liter. Okay, so I've got a mole, and if I put 1 mole inside my 1 liter beaker. This would have concentration of 1 mole per liter, or it would have a concentration of 1 molar, or 1 molarity. It could be said either way. If I take and put 2 moles inside my beaker, that would be 2 moles per liter. Or I could have 1.5 moles per liter, or just a half mole per liter. So working out some example problems here. What is the concentration of 1 mole dissolves inside 2 liters? So I would take 1 mole divided by 2 liters. That would give me 0.5 moles per liter, or 0.5 with capital M molarity. So if I put a half mole inside my liter, that's the same thing as having an entire mole. If you imagined I had another beaker over here, I would have 1 full mole in 2 liters. Okay. Next one asks, what if I have a half mole dissolved in 0.25 liters? Okay, so I take 0.5 and I divide that by 0.5 moles divided by 0.25 liters to find out what that is. That would be the same thing as 2 moles inside per 1 liter. Okay, so when I look at that, again, a quarter liter would be, if I put a half mole in a quarter liter would be down here. So in my entire liter, I would be able to fit, so 1 mole would fit then in a half a liter, and then 2 moles would fit in my entire liter. Okay, probably done doing things with pictures there. You probably think it's really mean that I'm splitting moles in half. What if I have 3 moles in 12 liters? 3 moles in 12 liters, if I divide it out, would be equivalent to saying that I would have 0.25 moles per 1 liter. Or what if I have 0.01 moles divided by 20 liters? I'll leave that one up to you. I don't want to grab my calculator. Okay, plus we got to make sure I'm already halfway through my time on the video here. The conversion factor we use for molar mass, conversion factors we use for different conversions. We use the molar mass of the compound sometimes. Sometimes we use the concentration to convert between different units. Sometimes we use Avogadro's number. And also we can use ideal gas law, and we'll get more into that later. For now, I'm just going to tell you that for standard temperature and pressure, that's what STP stands for, 22.4 liters is 1 mole of an ideal gas, and most gases are close enough to ideal. So we can put this into kind of like a graphic. This is called the mole island. We put moles at the center, so moles is the common thing that with moles you can convert to everything else. Everything has to go through moles. So if I have particles and I want to go 2 moles, this bridge tells me I have to use Avogadro's number. If I have moles and I want, let me just highlight. So again, if I'm going from particles to moles or back again, I use Avogadro's number. If I'm going from moles to mass or back, I use molar mass. If I'm going from moles to gas volume, I use the fact that it's 22.4 liters per mole. If I go from moles to liquid volume, I use the molarity. Okay? I do have a simulation, or not like, I don't know if simulation is the right word, but I do have like a mole calculator online. You can find it by going to my site and then going to Flash Lab Simulations. And once you're there, you'll see something that's called mole calculator. So you get to it and it tells you how to do it. You hit start and you get this cool little graphic thing with all the different islands that I just showed you. Okay, so let's say, for example, I know how many particles, the way you use this, maybe play around this more in class. So if I have something, let's say I have 6.02 times 10 to the 23rd particles, and I want to know how many moles is that? Well, that's 1 mole. So I click on the arrow that goes between those islands. Okay, let's say I have 22 grams of water, and I know that the molar mass of water is 18.02 grams. And I want to know, well, how many moles is that? That's 1.2 moles. How many particles is that? That's 7.35 whatever times 10 to the 23rd particles. One thing this simulation does not do is it does not do significant figures. You need to do that for yourself. Okay, so that's a tool that's available for you to help you like check on homework and things that you're doing, so you make sure you're doing it okay. Okay, let's work out an example problem together. And I have a bunch of different example problems here, and I only have about 4 minutes left in this video, and I don't have time to work out all of these for you. So I'm just going to pick a trickier one, and maybe you should try to work some of the rest of these yourself using a common thing, or we can work out a few of them in class tomorrow. Okay, just so you can kind of like ask questions as we go. So I'm going to pick one of the trickier ones. I'm going to pick this one right here. How many grams of sodium chloride would you need to make 3.5 liters of a 1.5 molar solution? So I'm going to go back to this and look at, well, where am I trying to go? So it says how many grams. Okay, so if I go back, whoops, wrong way. If I go back to this, I want to know mass. That's where I'm trying to get. Okay, so I know to get mass, I'm going to have to go this way. So I'm going to need to use the molar mass. Okay, wrong way again. Boy. Okay, it says I want to make 3.5 liters of a 1.5 molar solution. So I am down here. I was given information for liquid volume. I was told I have 3.5 liters. Okay, that's my liquid volume. I was given my molarity. It's a 1.5 molar solution. The one thing I was not given is what is the molar mass. So because you can see that I have liquid volume, I've got to go 2 moles. Okay, so I've got to get here. Once I'm at moles, I've got to go 2 mass. So I take molarity. So I've got 3.5 liters. I want liters to go away. I'm going to use my molarity. Molarity, remember, instead of the big capital M, we can think of it in terms of moles per liter. Okay, so I want liters to go away, so I'm going to put that on the bottom. I want to get to moles. I put that on the top, and it's 1.5 moles per 1 liter. So liters goes away, and I will have moles. So now I just have to take 3.5 and multiply it by 1.5. And that's 5 1/4, so 5.25 moles. So now I know I have 5.25 moles. Now that I have 5.25 moles, I need to use the molar mass. So I have 5.25 moles. I'm trying to get to mass. So for mass, that's units of grams. I want to get rid of moles. Molar mass has units of grams per mole. I just need to know what is the molar mass of NaCl. I'll go to my periodic table, I'll look it up, I'll do all the math, and I'll find that it is 58.44 grams per 1 mole. So I multiply 5.25 times 58.44, and I'll find that that is 306 or 306.81 grams is what my calculator tells me. Now once I'm done, I check my significant figures. In significant figures, I had 2 significant figures to start with, and so I'm going to, instead of 306.81, I'm going to have 310 grams is then my final answer. I can double check that with my mole island calculator. So I'll go back here. Entering this was in milliliters and that was in liters, so it's 3.5 liters. This is 3,500, whoops, not 1,000 liter or milliliters, so 3,500 milliliters. 1.5 molarity. My molar mass was 58.44. Calculate moles again, 5.25. Calculate grams, 306.81. I know I did it correctly. We'll certainly work a couple of these in class before I turn you loose on your assignment, starting with the ones in the example problems. Okay, hopefully this will give you a good start in terms of what we need to do. And again, try to answer some of those example problems on your own would be great.